let us study about an AC circuit containing only an inductor. Okay, an inductor is just a coil of wire. Okay, and we send an AC current through it. Okay, let's see how to draw it now. So we have a coil like this way. This coil is the inductor, and then we have the AC voltage here. Okay, so this is the inductor. L is stands for the inductor or the coil here. Okay, now let's see what's the applied voltage that we give. Okay, we give an applied voltage. Okay, so the applied voltage, okay, that means the voltage that we give, that is V is small v is equal to capital V, okay, Vm sine omega t. Okay, this we know how it comes. Okay, next what happens is, see, this is a coil now. Okay, when you send a EMF through it, it will produce back EMF. Okay, so let's see the back EMF it produces. Back EMF. Okay, this is due to the inductance now. Okay, the back EMF, that is epsilon is equal to minus L into di by dt. Okay, now what happens is, in this thing I am going to apply the Kirchhoff's loop rule, that is Kirchhoff's second rule. Okay, so applying Kirchhoff's second rule or loop rule. Okay, applying Kirchhoff's loop rule. Okay, so you apply the Kirchhoff's loop rule here. Okay, so this is a voltage that we give. Okay, small v is a voltage that is given here. So small v, and then we have this thing here. Okay, that is epsilon. So actually, what is the Kirchhoff's loop rule? The algebraic sum of all the products of all the voltage EMF is 0. Okay, so v plus small v plus this EMF here, that will be equal to 0. Okay, so if you add all the EMFs, that will be equal to 0. That's all. Now substitute the values in C. Okay, so let me write here, substitute the values. Okay, instead of v and small v and e, that's epsilon, you substitute the values here. So small v we got, that is Vm sine omega t. Okay, plus epsilon, what we got, that is minus L into di by dt now. So the plus sign will go away. We do not write the plus sign. So we write here minus L into di by dt, that's equal to 0. Okay, now we'll take this minus L into di by dt to the right side. It will become plus. Okay, so what we get is Vm sine omega t is equal to L into di by dt. Okay, now our aim is to find this di only. Okay, so what you do, cross multiply this dt upwards and bring the L downwards. So what we get is Vm by L, I'll bring the L down. Okay, sine omega t. So what happens is, I brought the L down. Okay, multiply dt now. Okay, into dt, that's equal to di. Okay, now rearrange. So on rearranging, what happens is, we get here di is equal to Vm by L, okay, into sine omega t dt. Okay, this step we'll get. Okay, let me, we have to now continue this by integrating. Okay, so let's see how to do that. Okay, so integrating both the sides. Okay, so, and before that also, this equation was there now. Okay, this equation we will name it as equation 1. Okay, so now let me erase all this. Okay, and then we will continue the integration. Okay, let me continue the integration here. Okay, on the right side, this side, left side now. Okay, so what we get is integration of di is equal to integral of this Vm by L, okay, and then you get here sine omega t dt. Okay, now you see integration of di is what it is, I. Okay, small I is equal to, and you see this Vm by L. Vm means what? The maximum voltage. Okay, L is the inductance. So Vm by L, you can take it out. Okay, so you can take out Vm by L from the integral, and the right integral of sine omega t dt. Okay, now we know integration of sine theta is minus cos theta, but this is, we get integration of sine omega t. Okay, so this is of the form, okay, right here, integral of sine ax. Okay, So integral of sine ax, if you see, that's equal to minus 1 by a cos ax. Okay, this is cos ax will come. Okay, so this is of the thing here. It's learned in maths, I think so, in 11th. Okay. 11th maths you learned about integrals. Okay, in that integrals it will come like this way. Okay, integral of sine ax, and there is a constant also, but we're not using constant now. Okay. So this is of the form. So let's now use this formula here. Okay. So what we get here is Vm by L. Okay. Now instead of this a we get omega. Okay, we got omega. So what we'll get is minus, and then cos, we have now cos ax. Instead of ax, what you have tried? You have tried here omega t. Okay, sin ax, and when we get minus cos ax. Okay, and this 1 by a was there now. So instead of a, what we have? We have here omega. Okay, so it's like this way, ax. Okay, instead of a you have omega. So bring this omega down here. Okay, run down. Okay, let me rub it out. Now this is very clear now. Okay, let's now go to the next step here. Okay, so now cos omega t is there now. Okay, and then you also have a constant also. So when you integrate, actually there will be constant also. Okay, so this formula will also get a constant. I didn't write the formula fully. So constant here, we don't use the constant now. Okay, so let us take this thing. Okay, this cos omega t. We will see what is the value of the cos omega t. So for that again we'll use the trigonometry. Okay, so in trigonometry you have learned that cos theta is equal to sine of 90 minus theta. Okay, this formula you learned in trigonometry, maybe in 11th I think so. Now if you see, minus cos theta will be equal to minus of sine of 90 minus theta. Okay, it's very clear. So again minus cos theta is equal to minus sine 90, we can write as pi by 2. Okay, and theta, instead of theta what we can write is, we can write omega t. Okay, omega t is equal to minus sine, instead of 90 we get here pi by 2 minus theta. Okay, so theta again that will be equal to omega t only, sorry. Okay, instead of theta you are writing here omega t. Okay, very same, only same formula. What I did is, instead of theta I written here omega t. Okay, so this is now clear. Okay, next what you do is, you take the minus sign inside. Okay, so what will get here, sine of minus pi by 2. Okay, and minus into minus will become plus omega t. Okay, it's clear. Now you can rearrange and write. So what you get here is sine of, okay, omega t minus pi by 2. This pi. Okay, so it's now clear. So minus cos omega t is equal to sine of omega t minus pi by 2. This is very, very important. Note down. Okay, now then you know how it comes, how next step comes. So now we know this thing. So let's write the equation, substitute here. So what we get is Vm by L omega, and here what we get is sine of, okay, omega t minus pi by 2. Okay, so this value we get. Okay, so instead of writing this Vm by L omega, we can write as Im. Okay, so here I is equal to Im into sine of omega t minus pi by 2. Okay, so this is the equation we get here. This is the equation for the current. Okay, here we can write here where this Im is equal to this Vm by L omega. Vm by L omega. Okay, so this is the equation of current. This is equation number 2. Okay, now equation 1 we know. Okay, we'll come to that now. Okay, and then we'll see the phasor diagram also. Okay, so equation 1 what we have is V is equal to Vm sine omega t. Okay, this was the equation 1. So we compare 1 and 2. Okay, what happens is, we can see that this is sine voltage here, sine omega t. See the angle here. This is sine omega t. But here we get here omega t minus pi by 2. That means what? The current is lagging behind. It's less by pi by 2. Okay, pi by 2 means what? 90 degrees. Okay, so that's very important. So let me rub all this, and then we'll go to the phasor diagram also now. Okay, so I'll write this now. Equation 1 and equation 2 I'll write down, and then we'll proceed now. Okay. Then we'll go to phasor diagram. Okay, erase this right side now. Let us see now from equation 1 and 2. Okay, so from equations 1 and 2, okay, we see that the current here, this is the equation current, I is the current. Okay, the current is behind the voltage by how much? Pi by 2. We can write here minus pi by 2. So you can see that current is behind, we say, means we say current lags, L-A-G-S. Okay, current lags behind voltage, okay, voltage by pi by 2. Okay, that is 90 degrees here. Okay, let's now see the phasor diagram for that now. Okay, let me erase all this and we will go to the phasor diagram, how the current is lagging behind the voltage. Okay, let me draw the phasor diagram for that current lagging behind voltage. Okay, that is for the inductor. Okay, let's see the waveforms now. First, let's see the waveform of the voltage here. Okay, so voltage I'll draw like this way. So this is the waveform of the voltage. It is a sine curve that we know. So this is the waveform of the voltage. Let's draw the phasor for the voltage here. So phasor means what we know, it's a rotating vector. It rotates in anti-clockwise direction. So I'll take this point here. Okay, and then I put dotted lines like this way. Okay, and then I'll draw the phasor for the voltage. So this is a phasor voltage, that is V. Okay, for voltage this is V here. Okay, actually the length of this vector will be Vm, that we know. Okay, we'll come to that little later. So this is for voltage here. Okay, and then the angle it makes, you see, that is omega t. It makes with the x-axis. That's very, very important here. Next, what we do, we'll see the current here. Okay, the current is lagging behind the voltage. It's starting at a lesser angle here. Okay, so for current here, I'll draw like this way. Shall I go this side? So actually before that, okay, we'll mark the angles also. This is pi and this is 2 pi. Okay, this is 0. Okay, let me draw the current here, the graph for the current. Okay, if you see the current waveform, it will be like this way. Okay, you have to extend this. Okay, so this is a graph for the current here. Okay, actually there are instruments called as oscilloscopes. On that you can see the waveforms there. Okay, now you can see the current starts little less only. See, it starts first. Okay, voltage starts first and the current starts less only behind it. Okay, this angle you see, it will be pi by 2. Okay, let's see that now. For current we'll draw a vector here. Okay, so let me choose a point here. Okay, let's see how it comes. I'll see it later. So we'll put dot lines here. Let's see the phasor now. Okay, and then I'll draw the current phasor. So this is the phasor for the current, that is I. Okay, now you see the angle here. Okay, between the voltage and the current, this angle will be 90 degrees. Okay, so this angle is 90 degrees here. Okay, that's why they say the current is lagging behind the voltage by 90 degrees. Okay, so next we'll see in this thing. Okay, actually the phasor diagram I have made a mistake here. This will be dotted lines only. Okay, not this one. Okay, you see the actual current will start here. Okay, current starts here. Okay, and then to draw the phasor only we put the dotted lines. Okay, so if you see this distance, okay, between here and here, okay, this distance will be pi by 2. Okay, that's how we say the current starts little later. Okay, it is lagging behind by pi by 2. Okay, now let us see the lengths here. Okay, this side and that side. Okay, that is for voltage and for this current here. So this will be, that is V is equal to Vm sine omega t. Okay, and the current, this length will be I is equal to Im, capital I, okay, capital Im sine omega t. Okay, so this is for the voltage and current here. Okay, next we will see what will be the length of the vectors here. Okay, and the current is equal to Im sine omega t minus pi by 2 also. Okay, because that was the equation. Okay, now we can see here, we'll mark this some other things here. That is, this point will mark as O, this point will mark as A, and this will mark as D. So you can see OA is equal to Vm. Okay, and then OB, okay, OB, this one will be equal to Im, the maximum voltage value of the current here. Okay, so from this you can see that the graph, you can see that the current is lagging behind by pi by 2. Okay, so current starts here. Okay, voltage starts here, current will start here. Okay, and remember these are dotted lines here. Okay, these are just drawn so that we can draw the phasor. Okay, that you should note it down. Next we'll see what's meant by the inductive reactance. Okay, let's now go to the next topic, that's inductive reactance. Now let us take the equation of the current that we got here, that is I is equal to this one, that is Im sin omega t we got now. Okay, before that we got here Vm by omega L into sine of this omega t minus pi by 2 we got. Okay, this for the inductor circuit. Okay, for inductor circuit we got, and then for resistor we got this before that. Okay, AC circuit containing only pure resistor. For reference, see that we get here Vm by R into sine of omega t. Okay, so this sine of omega t and this one, this shows the angle only. Okay, this is pure numbers, but now we compare this and this. Okay, so let me write down. Okay, so here we get here, instead of this we wrote Im. Okay, so we got here Im is equal to what we get is Vm by omega L for a pure inductive circuit. Okay, this is for inductive circuit. Okay, for inductor we got, but next we see for resistor. Okay, we're going to compare with. Okay, so compare with this Im is equal to this one Vm by R. Okay, so instead, I'm not saying this small I, I'm saying this instead of this I, what you write is I is equal to Im sin omega t now. Okay, so this Im will be equal to Vm by R. Okay, so Im is equal to Vm by R here. So instead of writing omega L, we can write as R now. Okay, this omega L is like a R here. Okay, this omega L we call it as the inductive reactance. Okay, so that omega L is called the inductive reactance. Okay, omega L here, take on the chalk. Okay, so omega L is the inductive reactance. Okay, this inductive reactance has a symbol that is we say XL. Okay, so XL stands for the inductive reactance. Okay, so XL means what? The inductive reactance. Okay, so inductive reactance is equal to what? Omega into L. Omega is equal to 2 pi nu. Okay, let me write that also. You come like this side. So XL is equal to, instead of omega you have to write here 2 pi f, the frequency, into L. Okay, so 2 is a number here, you know, pi is 3.14. Okay, or 20 by 7. Say f is a frequency, L is the inductance. Okay, so if we get this quantity, we can find the this one